topic 2.4, we'll be solving quadratic equations by completing the square. Now the process of completing the square would involve having a quadratic written as x squared plus bx plus c equals 0. This means that the first term here will be 1 rather than any other number. Once we have this, the completion of the square will be found by taking first b, which is this number here, finding half of b, and then finding out what half of b squared is. That process will complete the square. So it's a three-step process. So let's start here with number 1. X squared minus 4x minus 5 equals 0. We're going to solve this by completing the square. Completing the square is basically factoring, but you want to factor in such a way that both factors or binomials are the same. So what we're going to do is that we're going to remove the 5, we're going to put it to the other side. And so what we'll have now is x squared minus 4x, a blank space, equals 5. Now, what goes in that blank space? Let's do a little bit of work. The, 3 questions. What is b? What is half of b? And then what is half of b when it's squared? Well, b is negative 4. Half of b is negative 2. And when you square negative 2, we're going to get 4. So, what we'll do with that is that this is what we're looking for. So we're going to add 4 to both sides. Adding 4 to both sides completes the square. So when we factor, we're going to get x times x here, and for 4, 2 times 2, the sign's going to be the same, and they got to add up to negative 4, so negative 2 times negative 2. The 5 and the 4, that adds up to a 9. Now, from here, now that we factored, we're going to start compressing this into a x minus 2 all squared. That's the purpose of completing the square. It gives you the ability to compress the binomials into 1. Now from here, I want to take the square root of both sides. Square root here, and the square root here. And I'm going to have plus or minus. So as a result, we'll get, the square will go, we'll be left with the x minus 2. The square root of 9 will be 3 plus or minus. Okay. From here, we're going to add 2 to both sides. And as a result, we'll get 2. We'll get x is positive 2 plus 3, and x equals positive 2 minus 3. Our answers will be 5 and negative 1. Okay. All right. Let's do another one of these. Number 2. X squared plus 6x. Let's move this over a little bit more. Number 2. X squared plus 6x plus 3 equals 0. And once again, we'll be completing the square. Alright, so we're going to move the 3 over to the other side, create a blank space here. What we'll have is an x squared plus 6x equals negative 3. Okay, and this spot right here is where we're going to complete the square. So, the question is, what is b? What is half of b? And what is half of b when it's squared? Well, b is going to be 6. Half of b is going to be 3. And half of b when it's squared is going to be 9. 3 times 3 is 9. So we're going to say plus 9 over here. That completes the square. And then to balance the equation, we're going to say plus 9 on the other side as well. So when we factor this, this factors into two binomials. This trinomial factors into two binomials. And we get x times x. And for 9, that factors into 3 times 3. And the sign is going to be the same to get a positive 6. So positive, positive, positive. The negative 3 and the 9, they become 6. Okay, so the square is completed and we've got our two binomials. Then to solve for x, I'm going to start compressing this until this is nothing but an x on this side. So let's compress this down to a x plus 3 all squared equals 6. And then from there, I'm going to get rid of the square by taking a square root of both sides. And out here I'll get plus and minus. And now the square is gone, we're left with x plus 3 equals plus or minus the square root of 6. From here, I'm going to subtract the 3 from both sides. And we'll actually get two results. X is going to equal the negative 3 plus the square root of 6. And x is going to equal negative 3 minus the square root of 6. And those are our two answers. Okay, we're going to complete the square on this one, which is 6x squared plus 11x minus 10 equals 0. Now, the problem with this is that it's not in the completing the square form where the leading coefficient is 1. The leading coefficient is 6. So we're going to solve that by dividing everything by 6, and then we'll get our leading coefficient as 1. Let's see. There's a little marking here. So, dividing everything by 6 gives me the 1x squared plus 11 over 6x minus 5 over 3 equals 0. And I simplified everything. Okay, now that it leads with 1, I'm going to take this constant and put it to the other side. And now I have x squared plus 11 over 6x equals 5/3. And I'm going to complete the square and put it there. So, b, half of b, and then half of b squared. b is 11 over 6. Half of b, I multiply the 11 by 1, which is 11, and the 6 by 2, the denominator, and I get 12. Next, I square my terms, so 11 times 11 is 121, and 12 times 12 is 144. And that number completes my square. So plus 121 over 144, and plus, I'm out of room here, 121 over 144, and we'll return the 5 over 3 here. Okay. All right. Now I'm going to factor this right here into two binomials. X times x for x squared, and for 121 it's going to be 11 times 11, and for 144 that'll be 12 times 12. The signs are going to be the same, and they're going to be positive. Now, to add these two, I need a common denominator, which will be 144. Then I need this to be 144. I know this is 12 times 12, so if I take a 3 out of a 12, it'll leave 4 times 12, which is 48. 48 times 5, let's see, 48 times 5 will be 240. Because you take half of 48, which is 24, you add a 0, 240. And then the 240 plus the 121. This will be 361. All right, that's it. All right, now let's go ahead and compress these two into one binomial. X plus 11 over 12 all squared equals 361 all over 144. Now I'm going to remove the square, and then I'll remove the 11 over 12. So we'll take a square root, remove the square root, plus or minus. And here we're left with x plus 11 over 12. The square root of 361 is 19. And the square root of 144 is 12. And then from here I'm going to subtract 11 over 12 from both sides. This will give me two results. X will equal negative 11 over 12 plus a 19 over 12. And x will equal negative 11 over 12 minus a 19 over 12. On the left side, a negative 11 and a 19 gives me 8 over 12. And I can factor out a 4 out of both of these, factor out a 4 out of 8, and I get a 2. Factor out a 4 out of 12, I get a 3. Here, the negative 11 and negative 19 combine for a negative 30 over 12. I can factor out a 6 out of the negative 30, getting a negative 5, and a 6 out of the 12, leaving the factor 2. So these are my two solutions. Okay. Let's take a look at one more of these. So this will be 3x squared minus 6x plus 4 equals 0. Okay, we're going to solve this by completing the square, and therefore we need a leading coefficient of 1. Right now it's 3. So to get rid of the 3, we're simply going to divide everything by 1. By 3. Where's my cap? Okay, so dividing everything by 3. This leads us to x squared minus 2x plus 4/3 equals 0. Okay, and so now it leads with a 1. Now we're going to move the positive 4/3 to the other side, and it'll become a negative 4/3. Okay, and that leaves a space here where we will complete the square. Okay, b, what is b? What is half of b? What is half of b squared? B is negative 2. Half of b is negative 1. Negative 1 squared is positive 1. So, plus 1 here and plus 1 there. All right. Now I'm going to factor this trinomial to two binomials. X times x for the x squared, and 1 times 1 for the 1. The signs will be the same, and they'll both be negative. Adding a negative 4/3 and a positive 1 is basically adding the negative 4 over 3 and a positive 3 over 3, which will be negative 1 over 3. So compressing this, we get x minus 1 all squared, and over here a negative 1 all over 3. Okay, now let's begin to solve for x. We're going to take the square root to get rid of the square. Square root here, plus or minus. Okay. Now, you notice that 3 is not a perfect square. I want to turn 3 into a perfect square, so I'm going to multiply it with another 3. But I have to do that by multiplying this by 3 over 3. Okay. All right, let's continue. So we get x minus 1. And here, for 3 times 3, we can take the square root of that, and we'll be left with 3. On the top, the negative 1 comes out as the letter I, but the other 3 stays inside the root. Okay. Then from here, we're going to add a 1 to both sides. And the two answers that we'll get is x equals 1 plus I square root of 3 all over 3. And the other answer would be x equals 1 minus I square root of 3 all over 3. All right, now, we're now going to look at some techniques for solving quadratics, or solving things that are in the quadratic form, and using the substitution method. Okay, so solving quadratic forms. Okay, here's what a quadratic looks like. The basic quadratic is ax squared plus bx plus c, and then set equal to 0. But the form is this. The form is that whatever power x has on b, the power here will be doubled. So right now the power in the standard form, this power is 1 here. But over here next to the a, the x is squared. But if you have any number here, and the power is doubled over here, that will be the quadratic form. So if that's 1, that's 2. If that's 5, that's 10. If that's 15, that'll be 30. That creates quadratic form. Okay, here we have quadratic form because this is our b term right here. On the x, the power is doubled here for the a term. So what I'm going to use is substitution in order to get this into a quadratic look and then solve. Okay, so we're going to let the letter u represent the x squared right here. Then u squared would end up representing x to the 4th. So this now becomes u squared for the x to the 4th minus 5u plus 6 equals 0. And now we have the quadratic right here, the quadratic form. So I'm going to solve that by factoring u times u, and for 6, let's make that 3 times 2 for 6, and the signs have to be the same. So these add up to negative 5, and so I have u minus 3 equals 0, and u minus 2 equals 0, which implies u equals 3, and u equals 2. Well, now that we solved the form for u, we can go back and say, well, since u equals x squared, we can change this to x squared equals 3 and x squared equals 2. And from this stage, we can take square roots of both sides using the plus and minus. And we end up with 4 answers. X equals the square root of 3. X equals the negative square root of 3. X equals the square root of 2. And x equals the negative square root of 2. So a total of 4 answers from this. Okay. All right. Number 2 will also be found on the YouTube. So, in fact, this one right here, we're going to YouTube this one. Well, we will YouTube it, but well, I'll go ahead and solve it, but this one will be YouTubed. Okay, so we're going to let u represent the x squared minus 4 right here. Then that means that u squared will be represented by x squared minus 4 all to the second power, which is this term here. So now we have the u squared, when we use substitution, 3u minus 4 equals 0. And this now can be solved by using factoring. So binomial times a binomial, which will be u times u, and 4, the factors into 4 times 1. The signs will be different. So let's use a positive 4 and a negative 1. That'll add up and give us a positive 3. So we have u plus 4 equals 0, and u minus 1 equals 0. And this implies u equals negative 4, and implies u equals positive 1. Okay, now that we've solved for u, we can go back and make the substitution of x squared minus 4. So x squared minus 4 equals negative 4. X squared minus 4 equals 1. Alright, now it's solved by isolation. So I'm going to add 4 to both sides. And I get x squared equals 0. And here, I'll add 4 to both sides. And we'll get x squared equals 5. Taking the square root of all sides. And don't forget the plus and minus, which I almost did. I get x equals 0. There's no plus or minus over 0. But x equals the square root of 5. And x equals negative square root of 5. And from here, we have 3 solutions. 0, x equals square root of 5, and x equals negative square root of 5. Okay, number 3 is x to the 2/3 power minus 2x to the 1/3 power minus 3 equals 0. Okay, if I treat this as u, would this be a u squared? Well, let's take a look. Let u equal x to the 1/3 power. Then, what would u squared be? If I raise x to the 1/3 power, if I square that, I have powers raised to powers, which means that you multiply. A 1/3 multiplied with a 2 equals 2/3. So this would be x to the 2/3 power. So this is in quadratic form. Alright, so this will be u squared minus 2u minus 3 equals 0. And we'll factor this into 2 binomials. U squared will factor into u times u, and 3 will factor that in 3 times 1. And the signs will be different. So I'm going to use a negative 3 and a positive 1, and a negative 3 and positive 1 does give me a negative 2. So u minus 3 is equal to 0, whereas u plus 1 is equal to 0. Each factor is set equal to 0. This implies that u equals 3, and this implies that u equals negative 1. Okay, and from here, I can make my substitution of x to the 1/3 power equals 3, and x to the 1/3 power equals negative 1. Now, to solve for x, we have to make this 1/3 a 1 power. The way that I'm going to make this a power of 1, x to the 1 power, is I'm going to raise this to the 3rd power. Raising this to the third power will multiply the 3 times the 1/3, which will give me x to the first power. Whatever you do to one side, we'll do to the other. And so we will get x to the first equals 27. And we'll do the same thing for this side. I'm going to raise this to the third power. And powers raised to powers will multiply and give us x to the first power, which is just x. Raise the other side to the third power, we get -1 times -1 times -1, which is -1. And these are our two solutions. X is 27 and x is -1.